Hi, everyone. So today's lesson is on compound interest. Banking is really what we're talking about here. And I actually think that this topic fits better when we talk about exponential functions, which come up later in chapter 9. However, it shows up in chapter 7, I think just because it's working with exponents. That's the only real connection to the other stuff in this chapter. And it's a pretty easy lesson, to be entirely honest. I know the formula looks intimidating, but we'll get into that in a minute. So I just want to take a quick second and explain what do I mean when I say compound interest. I mean, I have a definition here, but let's really talk about what that means. So if you put $100 in the bank, let's say, and they say they're going to pay you 5% interest, okay? As long as it's compound interest, and almost all interest is compound interest, what's going to happen is after that 1 year has passed, they're going to do 5% of 100, which is just $5, okay? Tack that onto there, and now you suddenly have $105, okay? And this extra $5, that was free money for you, right? That was not money that you deposited that came from the bank. However, the next time they go to add 5% on there, you no longer have $100. So you're not just adding another 5 on there. You have $105, which if you do the calculation on that, 5% of 105 is actually 525. So you're earning a little bit more in interest. You actually would end up with $110.25. So you earned more from here to here where you added 525 than you did here where you added 5. Okay? And if we were to do this again, if you were to do 0.05 times that 110.25, you're earning even a little bit more. You're earning 550 this time. So that's the whole idea of compound interest, is you're earning interest on top of interest, all right? You're earning interest on money that you got for free, okay? And so hopefully you can see where this goes, that if you leave this money in for a long enough period of time, you're going to earn more money every year. You're going to get extra cash put into your account every year as long as you leave your money alone. And all you did was start by putting in the $100, okay? The other thing that gets thrown in, and we'll talk about this in a minute, is sometimes banks will compound like midway through the year, okay? So they'll say we're going to give you 5.5% interest, 5% interest on that $100, but we're going to do, you're going to start with 100. We're going to do half of that, so we're going to do 2.5% halfway through the year, and so you would end up with 102.50, okay? Because 2.5% of 100 is 250. And this would be after 6 months. So then at the end of the year, they would give you your other 2.5%. Okay, so grand total, you ended up with 5% interest, right? Just like this one did. Okay, except this one split it up halfway through the year and then at the end of the year. But if you do 2.5% times 102.50, you actually end up with 256 getting added on instead of just 250. And so you would end up with, and I know it's not going to seem like a lot, but you would end up with $105.06. Okay? As opposed to back here where we just did one jump of 5%, we got 105. If you split it up this way, 2.5 and 2.5, you actually ended up with a tiny bit more. And again, I realize that that tiny amount might not seem like a lot. The difference between having $105 or $105.06. But if you're talking larger amounts of money over longer periods of time, this is really going to start to add up for you. And then think about, what if your bank said to you, you know what, I'll give you 1% 5 times a year, okay? Then every time they do another calculation, you're earning interest on that free money that they gave you, okay? And so that's really, just in short, the whole idea behind compound interest, okay? It's when you're earning interest on interest money that was already given to you, okay? Earning interest on your free money. Okay, I'm going to shut my face off here. There we go. So let's get into how you actually calculate something like this. We do have this formula for compound interest, and it looks like this. I know, again, it looks intimidating. A is just the total amount in your account. So that's like the end result. That's how much you end up with. P stands for the word principal. Okay. And what that is that's your like initial investment. So in the banking world, principal means the initial investment, the amount that you put in. Okay? And then you've got 1 plus R is your interest rate. And you do want to make sure, typically your interest rate will be given to you as a percentage. You do want to make it into a decimal. You saw me doing that a few minutes ago. So like when I had 2.5%, I did 0.025. Okay, so you do need to make sure you make it a decimal before you put it in. N is the number of times you're compounding in a year. Number of times compounded per year. Okay, so this example that I did up here we were compounding twice a year, all right, because halfway through the year and then at the end of the year. Whereas back here, this was just a 1-year jump of 5%. Okay. This N here is the same as the N down there. Okay, so the N shows up twice in your formula. And then T represents time, always being measured in years. Okay. So if you need to pause for a second and get caught up on all those pieces, we will put this formula into use in just a minute, but that's what all of the things represent. Let's talk about these N values for a minute, okay, because that's what we have down here, the N values. This is going to show up as a word in your problems, okay? It's going to be given to you in terms of, it's not going to be given to you as a number, okay? So when I say interest is compounding annually, that's annually means once per year, so your N value would equal 1. Semi-annually, semi always means half. I don't even want to write that word down because I think it's going to confuse you. So this means halfway through the year. This is like that example that I did up at the top. So it's halfway through the year, but that means that you're compounding twice a year. So you actually want to use the number 2. You're not using 1/2, you're using 2 because you're doing it twice a year. Biannually, you're not going to see this one very much, but people get these two confused. Biannually means every 2 years, okay? So every 2 years means how much are you doing it every year? That would be 1/2. So again, this one really doesn't get used a whole lot, but I wanted you to see the difference between those two. Quarterly, okay, means 4 times a year. Monthly would be every month would be 12 times a year. And then we could get crazy and go with like daily. Daily would be 365 times a year. Sometimes it'll just say we're going to compound 6 times per year or something like that. Okay, so, but these are all your N values based on the wording of the problem. Okay, so let's dive in and actually try one of these. So example 1 here. Bank is currently offering a CD, which is like a savings account, paying 5.25% interest. So as soon as I see that, I know that's my R value, but I do have to make that a decimal. I know it looks like a decimal already, but you do have to slide the decimal point 2 to the left. So I'm going to make that 0.0525. Okay. Compounded quarterly, so there's one of those magic words. That means my N value is going to be a 4. Find the value after 2 years, so that's my time. If $1,000 is initially invested, that's my P value. Okay, so I found all those pieces written in the problem. All right, I'm just going to jot down the formula real quick. You probably have it there handy, but R over N to the power of N times T. You do need to know this formula, by the way. Okay, so after you use it a few times, I don't think memorizing it will be a problem, but okay, so we want to say A equals my principal, so $1,000, times 1 plus my interest rate of 0.0525 divided by n, which is 4, to the power of 4 times my time, which is 2. Okay, so that's how all my numbers would look like laid out in the formula. Now I just need to calculate this, and I'm going to type it in pretty much exactly how it says. Depending on your calculator, you may need parentheses up here, but other than that, you don't mess around with any other new parentheses. So I'm just going to get rid of all this junk, 1,000 times 1 plus 0.0525 divided by 4 to the power of, and in my calculator, because of the way it does my powers, I do need parentheses, 4 times 2, or you could just make that an 8, okay? If you need to, pause it right here so you can see how that's typed into the calculator. But that's what we should end up with, okay? 1109.95. This is money, so I'm rounding to 2 decimal places. So I'm saying that I'm ending up with $1,109.95. Okay. I always want you to think about this in terms of what you put in initially. We put in $1,000, so does this seem reasonable? And I would say yes. If you get a number that's smaller than $1,000, that does not make sense, okay? If you put in $1,000 and in 2 years suddenly you have $3 million, that probably also doesn't make sense. So just make sure that this number is reasonable in terms of the situation and the problem, okay? Okay, and that's really it. I mean, that's the majority of what you're going to do today is that right there. Just plugging numbers into the formula, finding the information in the problem, crunching numbers, and going. There is one other little piece, and that's called annual yield. And this little chunk was taken right out of your textbook, but I'm going to kind of explain it here for you. So annual yield is the overall interest rate after you've done all of your compounding. So I'm going to go back to this little example that I started with the 2.5% and 2.5%. Technically, this is a 5% interest rate total, right? Because you got 2.5%, 2.5%, you got 5% total. But if you look at it from beginning to end, okay, I actually earned $5.06 out of my $100, okay? So this is my extra money. I earned $5.06 out of my original 100. If I divided that and made it like a percentage, now that's out of 100, so it's really just going to be 5.06%, but I would get 0.0506, which is 5.06%. So even though it was a 5% interest rate, I actually earned 5.06% interest because of the compounding, okay? So like in a problem like this one, for example 1, and that's what this is asking me for, to get my annual yield, make sure that I'm looking only at 1 year's worth of time. So even though I can see that I earned $109.95 in interest, that was over a 2-year period of time, okay? So what I'm going to do is pretend that I'm investing $1, all right? Because $1 is the easiest one to make comparisons to later. I'm going to invest $1, all right, for 1 year. And again, I want to make sure I'm only looking at 1 year because I want to look at annual yield. Otherwise, I'm going to leave this exactly the same. So I'm going to put in $1 instead of my 1,000. I technically could still do this with the 1,000. I would just have to like compare it to the 1,000 later. Easiest just to look at the 1. I'm going to leave this the same. I still want to do 5.25% compounded quarterly. And this time I'm going to do 4 times, but I only want to look at 1 year's worth of time instead of 2. So I want to know, what did each individual dollar turn into at the end of that 1 year? Okay? So crunching the numbers exactly the same here. I really don't need to type in that 1. Hopefully that makes sense. So I'm just doing 1 plus 0.0525 divided by 4 to the power of 4. And I see, again, thinking about this in terms of money, although this is going to be a percentage, so I'm going to go a couple more decimal places. This becomes 1.0 So maybe I should go 4 decimal places. That's pretty safe. Okay? So what this is saying is that every dollar actually became $1.0535. I didn't mean to put another decimal point there. Okay? This represents your interest that you earned. And so this would represent, if I move that decimal point over and ignore the 1, 5.35% annual yield. Which hopefully that makes sense because my actual interest rate was 5.25%. So my annual yield is a little bit more than that because I compounded it 4 times, okay? So what I just found out here, again, by doing the calculation with $1 for 1 year, is what $1 would turn into. Then I can kind of knock off that 1, right? Because this 1 is just the dollar that I invested in initially. This represents the new extra money, and then I just move the decimal on that like a percentage. So I get 5.35% annual yield. Okay? Okay, that's really it for today. Homework assignment for tonight is Lesson Master 7.4b in your packet. It is a lot of questions just like example 1, so that's the one I'd be referring to the most. I do think there's one question with annual yield, but really example 1 is where you want to be looking. Okay, good luck.